right when they come out. For now, head over to Colab to get your code running right now. Create
All right, so good evening to all of you who are in this meeting right now. So welcome to the Head Start Machine Learning Session 2, which is about Python libraries. I'm Junbin. I'm a second year student in the SE course or software engineering course. So why not we have Chi Xiang to introduce himself?
Yeah, so I'm Xixiang, second year computer science AI artificial intelligence student. Welcome you guys.
Yeah, so thank you, Chi Xiang. So both of us are going to conduct this session. So before we get started, I would like to congrats all of you because you have gone through the session 1, and now we'll just proceed to session 2 Python libraries. I hope that you have all
creating and
have
maintaining
taken your
data.
attendance. You can just scan this QR code, or also, yeah, you can scan this QR code, and please confirm that you are filling up the right sheet, which is the Head Start Machine Learning sheet. What you will learn in this session is about Python. So we get started with some basics in Python language, the syntax, and also how do you write the Python code. And moving on, we'll explore about NumPy, Matplotlib, and also Pandas. Three of these are the libraries in Python, which will be used usually in machine learning and also data analysis. Moving on, we have also prepared a hands-on session for you to try hands-on on the one of the most useful libraries, which is Pandas. So please drop your question if you have any, and if you don't understand anything that we have, if you don't understand any of our explanation, so that we can clear your doubts immediately. So before this, in session 1, you have learned about linear regression and also what is machine learning, and we have also a hands-on session on how to write linear regression from scratch. So let's take a few steps back and look into how do we write Python, because Python is a language that we are using mostly in machine learning. Yeah. So all you need for this workshop is you can scan this QR code to get to the document where you will find all the links. But as this workshop progresses, we'll also share each of the link in the chat box as well, if you couldn't get to this document. All right, so let me stop sharing and I'll share another screen. Just wait for a while. Thank you. Okay. So let's get started with some Python basics. So why we learn Python? So Python is currently the most used language in machine learning, and also 57% of data scientists and machine learning developers actually use it, and 33% actually prioritize this language as in their development process. So actually another quite important point of using Python is that Python uh, is used a lot in machine learning, and uh, because there are a lot of libraries that are written in Python, and we can just use them like they are out for your reach, and you can just use it immediately, and it will actually make your development process easier. And also Python make code cleaner. So Python has something called a one-liner. I'm not really sure if you have heard before. So in one-liner means you are trying to fit in as many operations as possible in one line. So in Python, you are able to do so, and we'll see how to be a one-liner soon. So before we actually learn how to write Python, it is important to know what are the data types available in Python. So here I list out 4 data types that are quite popular and also mostly used while you're writing your Python code. So essentially there are string, integer, float, and Boolean. It might ring a bell because it is actually similar to what you learn in Java, if you have learned, or any other language. Just that they have a different syntax of expressing each of this type. Like string is str and integer is int. So there are other data types as well that I did not list down in this collab here. So you can just click on this link to find out. I believe you'll find a link in the chat box right now, which will lead you to this basic Python notebook. So when you click on this link, you will be redirected to this page right here. So this essentially is the Google Colab notebook. So I've included a video on explaining what Colab is. So we'll not go deep into that because that's not the main part of this workshop after all. But if you would like to play with the code on yourself, so you can actually just run the code here because now you are in the playground mode, which means any changes that you have made in this notebook will not interfere others' changes. So essentially, your changes will not be saved, right? So if you like to save your progress, which means you just like to play with the code and also save what you have done here. So you can also click on this copy to drive button if you found it below the navigation pane right here. So you can click on this and it will make a copy to a drive, to your personal drive, your personal Google Drive. So before you actually click on this, you need to make sure that you have signed into your personal Gmail account, or if you are a UM student, you should have a UM Syswa mail. So you can use Syswa mail to log in to store your this Jupyter notebook as well. So let's get started about running the code. So to run the code is essentially the key would be Control and Enter, or if you are using MacBook, it would be Command Enter. So let's get started with printing hello world. So in Python, printing hello world is just simply print and a bracket, and then just put a string in between, like what do you want to print it out. So it's like, for now, it's hello world. Just like other languages, we just get started with hello world. So the first time you run it might take some time because it is connecting to a kernel in the Google server. So it might take time and is initializing, as you can see right here. So we shall wait until it's connected and you shall see the output there. So yep, you have printed out hello world. So maybe you can play around with this code on your own machine. Like you can change this hello world to other random string and you shall see the result. So let's move on with the conditional statements. So you have learned this in Java as well. If it is essentially conditional statements are if and else statement, but in Python the syntax is quite special comparing to Java. So Java you have if, and else, but in Python you have actually if, elif, and else. So this elif is actually works the same way as else if, which is the condition that is not covered in if or else, so it is as if, else if. And while you're writing your conditional statements, you would use the Boolean operators to make some operations on the statements to look for the combination of this comparison or something. So essentially in Python we are using and or not instead of and a double ampersand ampersand symbol, but we are using the and English word here. So Python is you can say that Python is more English as it is using English word for its Boolean operators. And equality for comparing values. So in Python, it is similar to Java, which is use a double equal sign and also the exclamation mark and equal sign. So let's look at this example where I define a string. I initialize a string with this ML variable. And when I run it, ML is assigned, interesting is assigned to ML. And here I have a short if else statement. So if ML is interesting, I will print nice and also print you are right. So in Python, we don't have curly braces like this one. So essentially in Python, you have to take note of the indentation, because the indentation is where Python understand like this is a block of this if statement and this is a block of this elif statement. So if you mess up the indentation, it might run into error, or maybe you have some not compilation error, you have some runtime error as well, because or maybe some logical error, because that's not what you want the program to do. So please take note of the indentation. So you can use 2 or 4, just make sure that it is uniform throughout your code, right? So essentially, as you can see here, this is actually a block of code. If ML is interesting, you print nice and you're all right. If it's acceptable, you print you're not wrong. And if else, you print you are wrong. So let's run this and you shall see nice, you're all right. So moving on to built-in data structures. The data structures that we have right now in Python are the mostly used one are this, I think it's 4. Yep, there are 4 data structures that we are mostly used, but there are others as well. You can just refer to the actual Python documentation anytime. So in built-in data structures, the first one we have list. So list is actually just like arrays in Java, but with more flexibility. What are the flexibility that the Python list provides? So essentially, you can store different data types in the list. So essentially, in Python, you can store string as the first element and maybe integer as the second element. But it does, as you know, it is not possible in Java. As Java, the arrays are statistically typed, so which means you have to define the type for each of the array, and you can only store the value, the elements of that type only. So this one of the property of this is that it's ordered and mutable. So ordered, which means it maintains the order of you appending those data in. So it's like when I insert 1 first, the 1 will be the first one, and if I insert 2, the 2 will not be the first one, as it will be the second of this list. So essentially, it will remains the order of the insertion. And mutable, which means this list is mutable. You can change any of the elements in the list. Okay, so there's something very popular in Python that does not exist in most of the languages, which is what we call list comprehension. So list comprehension is a more convenient way of mapping each element to a function, or to do some operations or do some comparison. So we'll look into this later as well. So let's see this example. So we have random list. I create a random list with 1, 2, 3. So we have 3 elements, and this is I did not store the different elements. 3 of them are the integer. So when I call random list equals to, basically this is what I'm doing here. It's called the list comprehension, and it's also one way of achieving a one-liner thing. Yeah, because as you can see, I'm actually doing quite a lot of process in one line. So firstly, I look through the x in the random list. So this x will be for each loop, this x is actually each of this element. Like for the first loop is 1, the second loop is 2. The x will be 1 and the x will be 2. And moving on, I also compare if the x is equal to larger, if the x is larger than 1, I'll keep it. If it's not, I will just keep that value. So this is the second operation that I'm doing in this one line. And the third operation would be I add 1 to each of the value. So essentially after I run this, you'll see that I will be adding 1 to each of the value, but I will throw this 1 value out because 1 is not larger than 1. So when I run this, you shall see, yeah, so you have 2 plus 1 equal to 3, 3 plus 1 equal to 4, but 1 is dropped because it is not larger than 1. So I'm doing 3 operations in one line. Comparing to Java, you need to do a few lines, like probably 3 lines or something. But in Python, you are able to do it in just 1. So that's about this, and we shall move on with dictionary. So a dictionary is one of the most useful data structure in Python. So I'm not really sure if you have gone through this data structure, which is called hash map in Java. Hash map is not a built-in data structure in Java, and it is actually a imported library. So you might come across this hash map. It's actually a dictionary works the same way with hash map, which is it keeps a key and value pairs, and also you can retrieve those values with a key. So you can see here, I create a random dictionary, which is A and 1. A is the key, and after the colon is actually the value for that key. So if I want to retrieve it, I just call random dictionary, and with a square bracket, I put the key inside. So I've been referencing this key value pair, and I get 1 at the end. So if I would like to add a new key value pairs, it is as easy as just random dic and just put in the key like B and then assign it to 2. So what I'll get at the end is a dictionary that contains 2 key value pairs. And for the first one, I actually get 1 because I'm referencing the A key right here. So sets is similar to set class in Java. So yeah, you have also set. You have set in Java as well, not in Python only, and both actually works the same way. It is unordered and immutable. So unordered here means it does not maintain the order of insertion, and also immutable means that you could not change the value inside this set. If you would like to change this value, you have to just create a new set and assign it to this random set here. So maybe you can try it out. So let's say if I want to remove this C, I'll just random set equals to maybe A, B, and yeah, A, B. That's it. So you'll be removing 2 elements, which is 1A and 1C. So essentially, you don't have which means you don't have a method to change the element in place. You need to assign a new one. So all element in the set is unique, which means every time you insert something in, it will check whether the element exists or not. If it exists, then it will throw that value out. So the set will remain a set of unique values. So that's what the characteristic of sets. So moving on will be tuple. So in tuple, we have immutable and the properties are immutable and ordered, and it's used frequently to group elements up, and it's a small collection. So tuples can consist of 2 or 3 elements, but most of the time they are kept small. Yeah, so this is the tuple. So essentially here I have a list of tuple. So you can see right here. So I've done a side-by-side comparison of all the data structures here. List is mutable and is ordered. Tuple is immutable and ordered, and set is mutable and unordered. So most of the time we will kind of confuse with 3 of this data structure, and we are not sure when should we use which. So it is this comparison. I find this comparison useful personally. I'm not really sure about you, but I think this might help you to differentiate more about these 3 types of data structures. So we have also similar methods. Functions are just similar to methods in Java, and we take in an input and process it and output just like methods in Java. And functions are to group the operations so that it's easy to debug. So here I have an example of creating an example of a function, which is addition function, which add up the two parameters passed into this function, and I return the addition. So let's say I use this addition, just like Java, we just put in a bracket and the elements here, so you get 3. So Lambda functions. Lambda function is something quite special in Python, but actually also exists in other languages. It's actually similar to anonymous functions in JavaScript. So there are simple functions without names. Therefore, they are like a function without names. Before this, I've defined addition, but in this example, you can see that I did not give a name, but in turn I actually assigned this Lambda anonymous function to a variable so that I can use it in the future right here. So to define Lambda function, just put in Lambda and the input and x plus 1. So which means it will take in x and just +1 and return the value of x plus 1. So if you print out this, so I can use it together with the list comprehension that I've discussed before this, and it will just return the value of 2, 4, and 6, which adding 1 to each of the element. So which means it will look through the list, and for every element, it will add 1 to it. So after we're going through a lot of things about Python, like how do you write data types, what are the data types, and how do you write the print statement, and how do you do the conditional statement and built-in data structures, also all these structures that we have, and also writing a function. So before that, I would like to highlight this indentation as well. So when you're defining a function, you will need to maintain the indentation as well, so that Python knows that, okay, this is the whole function, right? So what's next is you can start doing practice at Python. This is the Kaggle Python tutorial. So you can do it hands-on while reading the instructions there. And also you can read more about Python in the Python documentation. This is the official one. And you can learn about OOP in Python, classes and objects. And also you can use the most important thing, which is you need to use Python often, just like how you learn the other languages. So that's all from me. So moving on, we'll guide you through how to use Python in those libraries that I've mentioned in the slides just now. So yeah, Qi-Xiang, over to you.
Yeah, all right. Thanks, Jumbin. So I will be sharing my window. Yeah, okay. So right now we are moving to the NumPy. So NumPy is one of the Python library. What is NumPy actually? According to the NumPy official documentation, NumPy is actually stands for numerical Python, which is the fundamental package for the scientific computing in Python. Yeah, so it supports like for large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions, so that they can operate on those arrays. So why we want to use NumPy actually? Yeah, there are several advantages compared to the Python list. Yeah. So the first of all is faster and more powerful than list. Yeah, why is faster and more powerful than list? Because NumPy does support basic matrix operation and some of the statistics operands, broadcasting, and also vectorization. Yeah, so these are some of the reasons why you prefer NumPy over the list. Yeah, however, NumPy arrays, yeah, it also known as ND arrays, comes with some of the restrictions. Yeah. First of all, NumPy arrays have a fixed size and creation, which means like when we create a NumPy array of 5 or size of 5, yeah, we cannot like expand it to size of 6 or reduce it to 4. Yeah, so this is unlikely like the Python list, because the Python list can grow dynamically. Yeah, so changing the size of ND array will create a new array and delete the original one. Second, the elements in a NumPy array are required to be of same data type, which means whenever we create a NumPy array with a data type of string, yeah, we cannot change it into integers, floats, or Boolean, or whatever. Yeah, so the memory inside will remain as same. Okay, so now let's us get started with NumPy. Yeah, first of all, we have to import the NumPy library and also create our first NumPy array. So we just call import NumPy as MP, and MP is actually the alias for the NumPy. Yeah, the short form, the abbreviation for NumPy. Okay, so we also gonna to print out the NumPy version. Yeah, so we are going to use the NumPy version of 1.19.5. So first of all, we have to create a 1D array. Yeah, because we have mentioned that the NumPy can create a lot of multi-dimensional array. So we just start with the most basic one, which is 1D array. Yeah, one-dimensional array. So it's really simple, sweet and simple. We just call the NP, which stands for NumPy, NumPy.array, and then we put a list from 1 to 5 inside that. So we have create the array and also assign it to my array. Yeah, we just print it and then we try to run this code, run this cell. Yeah, so when you print my array, it's actually a list from 1 to 5, but the type of it is stored inside the numpy.nd array. Yeah, so what is the shape of that? Okay, so the shape for the first dimension, or we call it dimension 0, since Python syntax start with 0. Yeah, so we just call it first dimension or dimension 0. Yeah, it's 5. And then the size of it will be 5. And the number of dimensions, because it's 1D array, so the number of dimensions will become 1. Okay, so let's us move on to 2D array. Yeah, so if 2D array, we have actually 2 layers of list. Yeah, and we call it as list of lists. So when we print it out, it will become embedded inside 2 lists. Yeah, so the class will remain as, the type will remain as the numpy.nd array. And for the shape, yeah, for the shape, this is the first dimension or dimension 0. This will be the second dimension of dimension 1. Yeah, so the first dimension will be across the row, which means we will be counting vertically, while for the second dimension, we will be counting horizontally, which means across the column. Yeah, so for the size, we just multiply every shape for their dimension. So 2 multiplied by 3 will become 6, while number of dimension and dim will become 2. Okay, so let's move on to 3D array. Yeah, it's just similar to a 2D array, just 3 layers of list. Yeah, when we are creating the numpy array. Okay, so when we print it out, it will become in this syntax. Yeah, so the first layer will be across the box. Yeah, so this will be the first layer or the dimension 0. Okay, so the type will remain as numpy.nd array. The shape, so this is the first layer, 1 and 2, so 2. And the second layer we have mentioned before, the second dimension is across the row, which means it is 2. And the final one is across the column, so it is 3. For the size, we just multiply them all and we get 12. And for the number of dimension, it will become 3. Okay. So this figure shows how we can determine what is their dimension. So for a 1D array, since it's only 1 dimension, so we just move horizontally and it's called dimension 0. Yeah, so when we move on to 2D array, we will go vertically first. The dimension 0 will go across the row, and the dimension 1 we will go across the column. Yeah, so when we move on to the 3D array, we will move into depth first as the dimension 0 or first dimension. Second dimension will be moved across the row. Yeah, so the 0 will become 1. And for the third dimension, we will move across the column. Yeah, so this is just a guideline for you to determine what are their dimensions. Okay, so right now we will move on to indexing. Yeah, for NumPy array, their indexing actually works similar like the Python list. Okay, so first of all, I just initialize a NumPy array. Yeah, this is NumPy array, and it works similar like the Python range. Yeah, so I will create a list of range 10, and 10 is exclusive. So it will start from 0 until 9, since the 10 is exclusive. Okay, so right now I write to like slice the index 0. Yeah, the Python will start with 0. So I want to get what are the value for the index 0. So just calculate this. Yeah, this is the first element, which is index 0. Yeah, so the answer should be 0 as well, because this is the first element. Yeah, and we can also access it from the back. So we can just put a negative, so the NumPy will know that we are going to access it from the backwards. Yeah, so -1, we start counting from the back, and it's -1, so it should be 9. Okay, so the third one, we want to access from the back, -5. So -1, 2, 3, 4, and 5. So we are getting the 5 here, and we want to assign the 5 into 50. Yeah, we want to change the value for the index -5. Yeah, so after changing the value, we just call the A again, this array. Yeah, so we are changing the 5 into 50. Okay, so right now we are moving on to slicing. Yeah, so the slicing, they are divided into 3 parts. So first of it is lower, and then colon, upper, and then stack. So the lower boundary is actually inclusive, while the upper boundary is exclusive. And the final one, the stat, will specify the stripes between the elements. Yeah, so I'm going to demonstrate about this. Yeah, so again, we are going to initialize the arrange function, the arrange method. This is starting from 0 to 9. So again, we want to slice the element. Yeah, we got the first one, which stands for the lower boundary, and the second one, which stands for the upper boundary. Yeah, since we want to access from the index 1 to index 3. However, the index 1 will be inclusive because it is the lower boundary, while the index 3 will be exclusive since it is the upper boundary. So we will expect the value from index 1, yeah, which means this until this, but the index 3 is exclusive. So we will get an array of 1 and 2. All right. So the another one, the negative index, negative index do works also. Yeah. So starting from the index 1 until the negative 1, and the negative 1 is exclusive. So starting from 1 until 8, because the last one is exclusive. Okay, so we can omit the boundaries as well. So for this case, I just omit the lower boundary. So this means I will get the value starting from the very beginning until the value I have specified here. So from the index 0 until the index 3. So 0, 1, 2, 3, I will get this 0, 1, and 2. Yeah. So for this case, I will be omitting the upper boundary. Yeah. So I will start from the index 3 until the end of that. So this is the index 3 until the end of that. Well, so let's just move on to this case. Yeah, in this case, we are omitting the lower boundary, yeah, and also the upper boundary, but we are instead we are keeping the steps. So the step of this is 2, which means we are taking every 2 steps, and in other words, every other elements. Yeah, so we are taking 2 steps from 0, and we take 2 steps to 2, and then 4, 6, and also 8. Yeah, so we are skipping the odd one because our each step will be 2, 0 to 2, 2 to 4, and 4 to 6. Yeah, so 0, 2, 4, 6, and 8. Okay, so these are the basic slicing for 1D array, and we will move on to 2D array. Yeah, we just initialize an array from 0 to 24. The 25 will be exclusive. Yeah, 0 to 24, and then we reshape it into 5 times 5 2D array. Okay, so the 5 at the first will be the first dimension. Yeah, dimension 0, and then this will be the dimension dimension 1, which is second dimension. Yeah, so you can always refer back to this figure. So this is dimension 0, this is dimension 1. Yeah, so when we shade it, and then we just print the output. So this is basically same as the figure show above. Yeah. Okay, so we want to access the coordinates for the 2D array. So this is the dimension 0. Yeah, it will move vertically, and this is dimension 1. So we will move horizontally. Yeah, so for the dimension 0, we want to access the index 0, which means the first row, 0, 1, 2, and 1, 0, 1, 2, 3, and 4. Yeah, for the dimension 1, we want to access the third column. Yeah, which means this. So the answer should be 3. Okay, so in the second case, we want to access the row 0 again. Yeah, the row 0, but in this time, we want to slice from the third column until the fifth column. Yeah, so the index is 3 until 5. So index is 3 until 5. Because the 5, still remember, we have mentioned before, yeah, the second one is upper boundary and it is exclusive. So we actually counting from 3. We will include the index 3 and also the index 4. So basically the last 2. So we will get an output of 3 and 4. case. So the third case, for this is a row, yeah, the dimension 0. Yeah, we want to access from the row 2 until the end because we are omitting the upper boundary. So from the row 2 until the end. So which means the second row, the row 2, the row 3, and also the row 4. Yeah. So these are the same case for the column from the second column, the column 2 until the end. So this column, column 2, column 3, and also the column 4. So we will get from 12, 13, 14, 17, 18, 19, and also 22, 23, and 24. Yeah, these are what we are going to slice. Okay, and the last one, yeah, this works as the same like the omitting the every other elements, which means we will take every 2 steps for the both column, both row and also the column. So for the row, we will skipping from 0 to 10 to 20, while for the column, we are jumping from 0 to 2 to 4. So we will get 0 to 4 because we are jumping each other. And for this, we are also jumping. So we will jump to 10 and then 12, 14, and so on. Yeah. Okay. So right now, we are giving you some times to try on this. Yeah. So we are giving you some exercise to slice the orange part. Yeah. Orange part is the first exercise. Yeah. And then the second part, the second blue one is the second exercise. Yeah. Try not to refer to the below answer. Yeah. Try to do it by your own. And then we are giving you 3 minutes. So after we are done that, so you can just leave your answer on the chat box. Yeah. So we are trying to count it from now. Okay. I'm giving you 3 minutes to do on the orange one and also the blue one. Yeah. Just try not to refer to answer below. Yeah, so I will discuss the answer right after 3 minutes. Yeah, so you guys can try to take a look and try to do it yourself. Okay, the times is up. Yeah, I didn't saw any answer at the chat box session. Maybe it's a bit hard for you all. Never mind. I will try to explain it further. Yeah. Okay, so I will try to explain it further. Yeah, so I hope that you all can get a better understanding on the slicing part. Yeah, so we will first look at the orange color one. Yeah, so basically, the orange color one, we want to get 0, 4, 10, 14, 20, and 24. Yeah, so for this case, we can just look at the first dimension. Yeah, which means the row. So in this case, we want to get the 0, which means the row 0 to row 2 and then the row 4. Yeah, this is actually skipping the another row. Yeah, so we will take a step of 2 from the row 0 until row 2 and also row 2 until row 4. Yeah, so in this case, we are getting the we are actually using this column 2. Yeah, because we are taking 2 steps each. Yeah, from row 0 to row 2 and then row 2 to row 4. All right. Okay. So this is the answer for the row, which means the first dimension. Yeah, so we move on to the second dimension. Okay, so we want to get the column 0 to column 4. Yeah, so there are two type of solution. The first one is using the step. Yeah, because we are jumping every 4 steps, which means from 0 to 4 is actually we are taking 4 steps. So we can use the first answer. Yeah, so the output will become the same as the orange color one, 0 to 4, 10 to 14, and then 20 to 24. Okay, so how about the second one? Yeah, we can try not to use this type of answer, the stepping one, but instead, because we want to get the column 0 and also the column 4, right? So we can directly access their column via the list. So we just mention at the column part, the 0 and also the 4. Yeah, so if we uncomment this, okay, so we will get the same answer for the above one. So either one will do for the orange color. Okay, so now we will move on to the blue part. Yeah, so we take a look at the row first. We have to slice for row 1, row 2, and also the row 3. Yeah, so for this case, we can just try to use the slicing, the method we have mentioned before, the lower boundary and also the upper boundary. Yeah. So because the lower boundary is inclusive, so we can just start from the row 1, while the upper boundary will be exclusive, so we can mention the row 4. Yeah, because row 4 is not included inside, and it will start at the row 3. Yeah, so we take a look at the column 1. Yeah, this will become the same as this. Yeah, so the column 1 until the column 4, and the column 4 is exclusive. Okay, so you get the answer same as the blue color one, 6, 7, 8, 11, 12, 13, and also 16, 17, and 18. Yeah, this is the first solution. The second solution will be similar to the second solution for the orange one. We are going to directly access the row by calling their row. Yeah, so the row 1, row 2, and row 3, we just make it inside the list. And so for the column, we just remain it as a slicing working. Yeah, so we just get the same answer for this. And the third solution will be the inverse compared to a second solution, which means I put the list. I call the list for the column part, while I call the slicing method for the row part. Yeah. However, the fourth one, yeah, which means both of them I just call their row or call their column and try to access it, but I didn't get the same answer compared to the first three, because if we are using this method, we are actually calling their coordinates, which means we are calling the row 1 and also the column 1, which means the coordinates will be 6, and then the row 2 and column 2, which means 12, while the row 3 and column 3, which means it is 18. Yeah, so we will basically get the coordinates for that. So we have to really be careful for this. All right. So right now we will move on to the fancy indexing. Yeah, the fancy indexing, again, I just initialize it from 0 to 9. Yeah, And then I want to put a condition of the array which I have initialized before. Yeah, so I want to get the array whereby the elements of it must greater than 5, which means it must be 6, 7, 8, and 9. So I want to create a condition, and I set the condition into the mask, and I just display it. It should be a Boolean condition, yeah, a Boolean array. The first one will be false because the 0 is greater than 5 is false. Yeah, the 1 greater than 5 is also a false condition. However, for the 9 greater than 5, it will be true condition. So it will be first at all and then the true at the back. Yeah, and then I try to put a condition into the A and I try to get it. So in this case, it will only help me to filter out the true condition, and it will help me to drop out all of the false condition, which means it will help me to remain all of the true condition. Yeah, the 6, 7, 8, and 9. Okay, so for the another condition, yeah, we can directly access it. Yeah, so we can just put a condition inside A and then the square bracket A greater than 5. Yeah, you can just call that. So it will get the same answer and the mask before. Yeah, and then otherwise we can put other type of condition like just now the A modulus 2. Yeah, which means the A modulus 2 equals to 0. Yeah, which means 0, 2, 4, 6, and also 8. Yeah. Okay, so right now we'll move on to element-wise operation. So again, I create an array, a numpy array starting from 1 until 6, but the 6 is exclusive. So 1, 2, 3, 4, and 5. Yeah, because the numpy supports broadcasting. So if we just call the whole numpy, and I plus it by 5, it will automatically help me to plus 5 for each of the elements inside the numpy. Yeah, this is one of its useful function. So if I just call a plus 5, yeah, all of the elements inside the numpy will automatically help be plus 5. Yeah, it will plus 5. And also subtract, divide. Yeah, the 2/ is actually the old style divide, which means the output will become an integer. This is the Python 2 one. Yeah, and then for the square root, we just call np numpy dot square root sqrt, and then we put the array inside. Yeah. And also the power double star. Yeah, and then numpy dot exponential exp, numpy dot logarithm. This is the natural logarithm, which means it is log to the base of e. Yeah, and this is a log to the base of 10, log 10. Yeah, all of them actually implement the broadcasting function. So it's really convenient and easy for us to use. Okay, so now we will move on to the matrix operation. Yeah, so we just create two matrices. The first one is 1, 2, 3, 1, 2, 3, a 2D matrix. This is A, and the second one is B. Yeah, 4, 5, 6, 4, 5, 6. And we can just directly add them by calling A plus B, A minus B. Yeah, we can also use the dot product of two matrices. So we want to dot between the A and also the B. Yeah, so the B, I will try to transpose it. Yeah, B dot T is actually B dot transpose. Yeah, and so I will dot it with the A. Yeah, so both of that will get the same answer. The dot one and also this alliance symbol are actually the same. And then the cross product. Yeah, for this is actually the inverse function. Yeah, we will call the numpy dot linear algebra dot inverse. Yeah, and then we just put our arrays inside, and it will help us to calculate the inverse of this array. Yeah, how about if the array doesn't have a valid inverse? So we can just call the pseudo inverse for the array. Yeah. Okay, right now we'll move on to the others functions. Yeah, so this will consist of mathematical and also the statistics one. Yeah, so I will initialize an array of 1 until 7 exclusive, and I will try to restrict it into 2, 3. Yeah. So this is the array 2 because the row will become the 2, and also the column will become the 3. Yeah, the first dimension and second dimension. Okay, so we will try to get the answer for the sum. Yeah, so by default, it will help us to sum up all of the values inside the array, which means 1 plus 2 plus 3 plus 4, 5, and also the 6, and it is 21. Yeah, however, we can also explicitly specify which axis we want to sum along. Like as mentioned before, if I want to sum along across the row, which means across the axis 0, yeah, I just mentioned it. A dot sum axis 0. So it will be plussing them from across vertically. Yeah, 1 plus 4, 2 plus 5, and then 3 plus 6. So it will be 5, 7, and 9. So if you want to sum up then horizontally, which means across the axis 1, yeah, you just call this. We just explicitly set the axis for us to sum along. So which means 1, 2, 3, it will become 6, while the 4, 5, 6, it will become 15. So this is really a useful function, and this is for the sum, and then their product, PROD stand for product. Yeah, so default it will multiply all of them. Yeah, and then for this we can explicitly set the axis. Yeah, and then CUM sum will stand for cumulative sum. Yeah, and then min and also the max. Yeah, all of them work similar. Yeah, however, sometimes we are not interested in the value of min max. So instead, we are more interested of the location of it. Where is the location for the minimum and where is the location for the maximum? This is really an essential one when we want to use machine learning. Yeah. So in this case, we can try to access it via the argmin and also the argmax. Yeah. However, the args method return the location in 1D, which means it's on a variable index of array. Yeah, the 0 and 5, which means the minimum is index 0 and the maximum is 0, 1, 2, 3, 4, 5, index 5 when we try to flatten it on the 1D array. Yeah, so if we want to return it back into 2D array, we can try to call the following code. Yeah, numpy.unvariable index, and then we put the argmin or argmax and also the shape inside that. So we actually get the coordinates of the argmin, and this is the coordinates for the argmax. Yeah. So another one will be P2P, which stands for peak to peak. Yeah, we will get the maximum one and the minimum one, and we try to minus them. Okay, and these are some of the statistics function: mean, standard deviation, and also the variance. Okay, so right now we will move on to the broadcasting. Yeah, the really important one, because the array of different dimensionality can be combined into the same expression. Yeah, which means when we get an array with a smaller dimension, it can be broadcast to the larger array without copying the data. Yeah. So in this case, we have two types of array. One is the column vector or column array. The second one is a row vector or row array. Yeah. By default, we cannot add both of them together because they do not have the same type of size. Yeah. So however, because we are using the NumPy broadcasting, we can actually add them together. Yeah. So in this case, the column vector, it will be elongated to horizontally. Yeah, we will expand it width. Yeah, so it will basically copying their content, their value inside that to the right, and also the for the row vector 5, 4, 5, and 6, you will be expanding downwards, and you will get the final answer for this. This is the output. This is the reason why NumPy has implemented the broadcasting. Yeah, it's really a useful one. However, there we have to take note that the current axis of either array must be 1. Yeah, so like for this case, the current axis for this is 1, both of them. Or either both of them has the same size if you want the broadcasting to occur. Yeah, so in this case, the first array is 5 times 5, and the second array is 6 times 4. Yeah, so if we cannot add the A and B together because they neither fulfill the both condition. Yeah, so it will come out with an error. Appearance could not be broadcast together. Okay, so we will move on to the final part, which is vectorization. Okay, yeah. So vectorization, first of all, we try to initialize a list and also initialize an array. Yeah, it is 100,000 from 0 to 100,000. And we try to get the time if we want to power for each element inside the list, we want to power it by 50. Yeah. So we try to get the time for it, and also the time for the array. Yeah, so for the time for the list, we basically get 77.4 ms per loop, yeah, millisecond. While we are using the array, we'll get 520 milliseconds per loop. Yeah, this is really a huge difference between the list and the array in terms of their time efficiency, because when we try to implement the array, is actually doing the kind of factorization behind the scene. Yeah, so that's the reason why there are huge time significance improve compared to the list. Yeah, so that's all for the NumPy tutorials. And if you want to explore further, there are several hyperlinks with this and the session here. Yeah, the first one is the NumPy official documentation. Yeah, the absolute basics for beginner. You can try to take a look. And the second one is NumPy tutorial by tutorial point. This is really a basic one if you want to take along. Yeah. And the third one is introduction to numerical computing with NumPy in SciPy 2019. Yeah, I think this is a 2 hours YouTube video. Yeah, so if you already study about some of the basics for the NumPy, you can try to take a look at this. And the final one is the NumPy cheat sheet by Data Quest. Okay, so after NumPy, we will move on to the Matplotlib. Yeah, so what is Matplotlib? It is actually a plotting library for the Python programming language. Yeah, it can create the static, animated, and interactive visualizations in Python. Yeah, so Matplotlib is actually the most basic visualizations library inside Python. So let us get started with Matplotlib. So we just import that. Most of the Matplotlib utilities will lies under the pyplot submodule, and it will usually import under the plt alias. Okay, so we just import matplotlib.pyplot as plt and also numpy.np. Okay, so we'll move on to the following cell. Yeah, we want to call the matplotlib inline. So this is actually the magic function in IPython. When we get this symbol in front, that is a magic function in IPython. And I found this from the official documentation. Yeah, so this basically explain what this line means. So with this backend, the output of plotting commands is displayed in line with front ends, like the Jupyter Notebook, directly below the code cell that produced it. Yeah, so the resulting plots will be then also will be stored in the notebook document. Yeah, so it means that when we already call this line, so whenever you want to create the plotting, it will be displayed directly under the code, directly under the cell. Yeah, so we just put the Jupyter Notebook, like, and in this case, the Google Collapse as the front end. Yeah, we just use it inside that. So how do we create a basic plotting? Yeah, so we just create the x, just put the x-axis. Yeah, we just initialize the x-axis from 0 to 10, and also the y-axis from 10 to 20 exclusive for the last one. And also we just call the plt.plot the x-axis and y-axis and just show it. Yeah, so we just created our first plotting in Python. And this is really a simple function with just 4 lines. So we can just create a really simple Python plotting. Yeah, so we just try to get some of the more elements to that. So how do we make the plot better? Yeah, first of all, I try to make sure the randomness is consistent throughout this notebook. So I just initialize the random seed number 42. Yeah, so which means this will make the coding become more reproducible. Okay, and I try to randomly generate 2 sets of data. The first one is the y1, y-axis, first y-axis 1, numpy.random.uniform. The low value will be 3000, the highest value will be 10,000, and the size will be 50. Yeah. And then the second, also the second random y, and also the x-axis. This is actually the length of y1 or y2, and it will be 50. Yeah. Okay. Then I will try to call the plt.plot x and y1, plt.plot x and y2. Yeah. So this is x-axis, this is y-axis, and I just show it. Okay, so this is the graph we are getting. Yeah, so the Matplotlib has a default option to differentiate two sets of data with different color. So one of the set will be blue, while the other one will be orange. Yeah, however, we can also do more than that because it will be better than we explicitly set the color of the data. Because if we get the graph from this, we actually doesn't know which color is stand for which graph. Like I don't know whether that the blue one stands for the y1 or the blue one stands for the y2. Yeah, we doesn't know about that. So we have to take more control. We have to control more on the graph. So we try to explicitly set the color of the graph, the data. So I just set the first color one into B, and then the second plotting to Y. So I just show it, yeah, as the graph below. The first plotting is the blue color one, and the second plotting it will be the yellow color one. Yeah. However, how do we know that the B stands for blue while the Y stands for the yellow one? And all of this can be found inside the Matplotlib documentation. Okay, so inside the Matplotlib documentation, yeah, so there is a list of color, the supported color aberrations with the single letter code. Yeah, so by looking at this, we know that the character B stands for blue, and also the character Y stands for yellow. So that's why we just put the first one to B and then the second one to Y. Yeah, so other than this, other than the color of the data, we can also change the marker and line style of the data. Yeah, so we can also find all of this under the Matplotlib documentation. So this will be the line style, and also this will be the markers. Yeah, so all of them are listed down inside the documentation. Okay, so I just made the first one line style into dotted line, the marker into full stop, yeah, the dot one. Or the second one, the line style will be the normal line, and also the marker will be cross X. So this is the resulting output. Yeah, okay. So as we can see, the blue one, we got the dotted line and then the dot between every point, while the yellow one, we get the marker at every point. So instead of setting the color, line style, and marker separately, you can actually combine them into one line, yeah, one part. So the format will become the marker first, and then line, and then color, and it has to be inserted right after y value in prt.plot. Yeah, so we try to get that prt.plot x y1. So right after the y-axis, we just initialize, we just put the color, line style, and marker. So the first one, the marker will be dot, and then line style, double dash, and also the B. Yeah, so the second one will just follow the above one, and then we just call it, and basically we'll get the same plotting as the above one. Okay, so so the graph is seems better now. However, we only ourselves that produce the graph knows that the blue line stands for y1 and the yellow line stands for y2. What if we want to present the graph to another else? So he or she doesn't know that, okay, the blue line stands for the y1 while the yellow line stands for y2. Yeah, he or she doesn't know anything about that. So we have to add the labels on the graph to let them know that, okay, the first line, the blue one, is actually the y1, while the yellow one is actually the y2. So while we are creating the plot, we just add the label arguments or the label parameters here. The label will be y1, and the second one, the label will be y2. And we have to call the prt.legend, then only it will display it. Yeah. If we didn't call the PRT legend, it also doesn't display this at the graph. Okay, so we know that the Y1 will be blue and the Y2 will be yellow. So normally the PRT.legend, you will find the best place to display the label. So we can also explicitly set the place to show the label. Yeah, as the belonging code, I just set the location to the upper right. Yeah, there are also another location like upper left or lower left, lower right. Yeah, just look through the documentation. Yeah. Okay. So for the next part, I will just add the grid line on that. So prt.read equals to true. Okay, so yeah, so right now we are coming to the final last one. Yeah, so we have to add the label for the x and y axis, also for the title. Yeah, so this label is especially important to let the audience know what the graph, what the plotting is trying to tell about. Yeah, so I just add for the title, we just call prt.title and then we enter our title. And then x label is the label for x-axis, y label is the label for y-axis. Yeah. So we get the title, the y-axis, and also the x-axis. Yeah. So this is how we are going to create the simple plotting using the Python. Yeah, this is much better compared to the first one. Yeah, this one. All right. So right now you have know how to create the plots under the Matplotlib. Yeah. So I'm going to introduce you all about different types of the plot within the Matplotlib. Yeah. So the first one I have introduced before is a line graph. Uh, Other than line graph, there are also some of the common plots. Yeah. So I'm going to introduce them to you. So the first one is the bar plot. Instead of calling the prt.plot, we can call prt.bar, and then we just put the x-axis, the y-axis. Yeah, so for the other parameters, I just put the label, the color, and also the width. The width stands for the width for the bar. Yeah, they are horizontal width. And also the legend, the X label, Y label, and also a title. And I just show it. So this is the bar graph. And also the second one is the histogram. Yeah, the population age, the the histogram beans. Yeah, and I will just call prt.his. Yeah, stand for histogram plots, and then the population age, and we set the beans, and the histogram type will be bar, the bar charts, and also this is the width, so 0.8. Yeah. And then all these stuff are the x-axis label, y-axis label, and also the title. And I just show it. Okay, let's move on to the scatter one. X, this is the x and y, and this is the color and size. Yeah, we just call prt.scatter, put the x-axis, the value for the y-axis. The s is stand for the size, so I just inside the size here. So if a value here is larger, so the size of the output will become larger. Yeah, this goes same as the color. If the value of the color will be larger, so the output it will become darker as well. Yeah, so this is the color maps. CMap stand for color maps. I'm going to use the green color maps, and the marker style will become cross X. The H color for the marker will become black. Yeah, there is an H color there, and the line width will become 1. Alpha is actually the transparency. Yeah, so I set the transparency into 0.75. Yeah, okay. So this is I also initialize the prt.color bar. So there is a color bar at the right side, and I also set the label for the color bar, which is satisfaction, and I just showed it. Okay, so for this is the error or stack graph. Yeah, this is really useful when we want to measure something over the time, across the time. So in this graph, I'm measuring the cumulative score across the time between 3 players. Yeah, so this is the X and this is the 3 Y, and I will set the label for every Y. So we just call the stack plot. Minutes is X, and these are the Y, and also their labels, and also enable the legend at the upper left location, and also title and show it. Okay, so let us move on to the pie, the last one. The slice is the portion of the graph of the plots and also their respective label. Now I will call the prt.pie, and then the slice, their portions, their labels, and then the wedge plots, which means the edge color I will set it to black. So there's a black color at every edges. Yeah, and also the title, and I just show it. Yeah, so these are the most common plotting under the Matplotlib session. And so I will go on to the really last one. So which means we can try to read from the image and then plot it out. Yeah, so I just randomly initialize the sum of the numbers and I just reshape it into 16 times 16 pixel and I just put it into the image variables and I just call prt.imshow, which stands for image show. Yeah, so I put the variables image and the color map will become binary because the value are ranging from 0 to 266 exclusive. Yeah, so I just call it and this will display the image. Okay. So that's all for the matplotlib session. If you want to get some of the further reading, you can refer to the matplotlib official documentation, which I have shown before. Yeah, so this one, the matplotlib official documentation, the matplotlib official tutorials, and also one of the matplotlib tutorial YouTube playlist. Yeah, so that's all for the matplotlib session. So right now we are taking a 5 minutes break. Yeah, so you can try to go to your washroom, yeah, to take some rest or other else. So we will be come back at 9:20.
Okay, everyone, welcome back from your 5 minutes break. So before we move on to the Pandas session, I would like to clarify a mistake that I found just now in the material given. So essentially for set, actually set is actually mutable instead of immutable. So essentially what it means is actually you can apply functions to alter your elements inside. So for example, when you look into the Python official libraries, you can see that you have methods such as remove, add, and so on. So sets are actually mutable, and but the elements inside should not be mutable. So you cannot store a list in a set. So that's what I would like to clarify. So if you have actually make a copy of the Python notebook just now, probably you need to edit it manually in the set section right here. So you can just double click and start editing, and also press escape to look into to have it to go into effect on your notebook. So for the table here is correct because set is mutable. So sorry about the mistake. So moving on would be the Pandas session. I believe you receive a link in the chat section for the Pandas notebook. So yeah, so let's get started with Pandas. So as usual, you'll be redirected to a notebook like this, and you can copy to Drive if you would like to save your progress. If no, then you can just run this code, run the code here freely. Yeah. So what is Pandas? So Pandas is a fast, powerful, flexible, and easy to use open source data analysis tool. So it is built on top of Python, the programming language, and of course you are using Python to implement Pandas in your code. So you have learned about basic Python, and we have learned about NumPy, which is doing numeric operations on numbers, and also we have learned about Matplotlib, about plotting graphs and charts for your data. But we did not learn how to store your data. I mean like visualize your data in a table form, and also to manipulate your data. So Pandas is the library for that. Let's get started with the code. The first thing you need to do to use Pandas, just like NumPy or Matplotlib, is just you need to import the Pandas to your current workplace. So it is import Pandas as PD. So the PD here is actually a alias, like what Chi Xiang said just now in the NumPy session, which means that if you give an alias to this Pandas, so throughout your code, you will not need to type out Pandas, and you can just use PD instead. So PD means Pandas. Yeah. So but you save a few keystrokes here. So that's about that. And also in this session, we'll be using a little bit of NumPy. So we'll import NumPy as NP. So let me run this. You can run it with Control Enter. I think there's a technical issue where you could not see the Pandas notebook, right? So let me stop sharing and share it again. Right, so could you see the Pandas notebook right now? Okay. All right, so I think it is you are able to see it. So for example, this after we have imported, I just now what I did is just running the Pandas here. So I import the Pandas to your notebook, and you're able to use it in the future code, right? So moving on is about it. We will learn about data structures in Pandas. So in Pandas, we have two type of most important data structures, which is series and data frame. So series in layman term is actually a column in a table. So like I said just now, a Pandas actually stores the data in a table form. So what we know about table before this is table has rows and columns. So that concept applies to Pandas as well. Just that there are specific term, special term to refer what is column and what is a table. So essentially, series is the column and data frame is the table. So there are no row in the pandas because essentially data frame is made out of a list or a collection of series. So that's what data frame means in pandas. So let's see this code where I initialize a name array here, or a name list, Python list, and also we have a grade list. So before I create a data frame, I will need to create a series for each of this list right here. So I just put in the constructor pd.series and I put in the name list right here. And so for grade series, I have pd.series and then I put in the grades list inside the constructor. So this will create a series called name series and also a series called grade series for us. But now we have two separate series and we would like to combine them into a data frame or into a table, in other words. So what we need to do is just call this constructor called pd.dataframe, and we put in a dictionary. And in this dictionary, you actually have a key value pairs that where the key is actually the name of the column or the name of the series, and also the value is the series that we have right here. So as you can see, the first column is name and the series is name series, and the second one is grade and grade series. So let me run this, and you shall see a table like output, which is this is actually the output of the data frame, and you'll see there are two columns right here. So the leftmost column, you can just ignore it for now because it's actually the index for your data frame. So we'll talk about index in the next session. So index is used to reference the row. By default, the index is numeric, starting from 0, but we are able to set which series to be the index. So previously, when I create a data frame, I did not specifically define like which column should be the index. But now what we're going to do is we're going to set the name column, the name series as the index of this data frame. So after I run this, you'll see that the leftmost column that consists of numbers 0 to I think 4, right? Disappears, and now we only left with two columns, and the first column is a name, which contains a name, and those names are bold. When it is bold, it means that it is now the index for this data frame, and we also have the grade, which is A, B, C, and AA. So this is about index. So with index, we are able to locate the row of this data or this observation. So we look into how to locate data in the next section. So now we have the data frame. We have all the data in the data frame, but we would like to retrieve those data from the data frame. So what can we do to retrieve those data? Like in normal situation, like while we are using Excel or using maybe just a table, we know that there is some sort of like a coordinate system where we can just refer like the row A and maybe the column A or something in Excel or something like that. So row 0 and column A. So what we need to know is how to retrieve those data from the data frame instead. So forget about this data frame right here, because we are now going to refer to this one, which is the original, the one that we have initially. So locating the data is just using a coordinate system in Pandas, but the coordinate system is quite special, where there are two types of ways you can use to locate those data. So the two methods, the two functions that we have are df.ilog and also df.log. So there are using these two different methods or these different functions, you are using different things to reference those rows and columns. So first of all, we can use numeric index, and also you can use word keys. Right, so we'll go into how to use ilog and log later. So first of all, I would like to get the arming grade. So when you look at this data frame here, you can see there is arming right here, and the grade is A. So how do I retrieve this A out? So you can see in the code here, I'm referencing using index because I'm using ilog. So the difference between log and ilog obviously is the letter I right there. So I must mean something special. So in this situation, I is actually, for me, I personally remember this as index. So whenever I see I log, it means I'm using the index or the numeric index to reference those rows and columns. So the first, it is in the first row. So Python uses zero based indexing. So it is 0. And also the first, the second, I'm sorry, we are not referring to this one, but this one. We are referring to the second column right here, because the first column is name. So it's 0 and 1. So you get A right here, the intersection of 0 and 1 here. So like you can see here, I'm referencing 0, 1. So the first one is actually the row and the second is the column, right? Second one will be arbu grade, and you know the drill. So it's 1, and also the second column is 1. So you get B. Okay, so this same logic moves on, and you will see that something special right here when I want to get all the grades. So you see there is a colon. So the colon here means actually the colon doesn't has any numbers before and after. So it's different like what you see in maybe the NumPy session where you try to assign like a 0 to something. So this colon without any numbers actually means I'm taking everything that in that range. I mean everything that we have. So as you can see, the colon is actually at the row section right here. So I'm taking every row, that what it means in English, every row, and I'm taking every row, the grade for every row, because I'm referencing the second column right here. So it's actually the second, the grade of, sorry, I'm referring to the wrong one again. So the grade of all the rows. So I'm getting A, B, C, A. So if I run this, you shall see in all grades, I'm getting A, B, C, A, and Arming's grade, I'm getting A, and Abu's grade is getting B, so which is the right one, the right grade. So another way of referencing or locating those data is log. So log doesn't has an I there, so which means it is not using index, but it uses word keys instead. So what are word keys? So word keys are actually like for example, here we are referencing using grade instead of 1. Before this, we are using 1 to refer to the column grade. So now we are using the grade, which is the name of the column. So that is what I mean by word keys essentially. But you might see that, oh, this is 0. This is a number. So it is actually an index, not. So it is actually an index, but as you can see in this data frame, I said that by default, the index that we get for each row is actually starting from 0, and it increments every row. So you get 0 to 4. So maybe you'll understand better as we progress, because after that I'll try to remove one of the row, and you'll see that actually the index here will not refresh. Like although I removed the first one, it was the arbu will still remains as 1. So that is actually it's like a word key already. It's not actual index. So this is why we have numbers right here. And this same goes to the one column actually getting all. So let me run this. So here what I'm doing is I'm actually comparing the previous answer that we get, like Arming's grade, and compare with what we are doing with the log here. So you can see that we get true for everything. So which means both ways will retrieve the data in the same way. So another way of locating the data is using Boolean list. So Boolean series, or in other words, yeah. So for example, I would like to get student with A. So how do I refilter through this data frame to get only students that has a grade A right here? So what I will do first is that I will be comparing the grade 1 by 1 with the letter A. So then I will get, by comparing 1 to 1, I will actually get like a Boolean, like A, this first one should be true, and false, false, and true, true. So I will get another series, a new series of Booleans. So that's what I'm going to do right here. So you might see that I'm actually surrounding it with a square bracket and write this student df in front. So this is what I'm doing is I'm trying to use this series of Booleans that I get to filter this data frame right here. So you can see here is print student df dot grade equal to A. So this is basically what I'm doing is I'm trying to let you visualize what this returns, because you might not get what this returns when you just print student A. So yeah. So you can see that what I get for student df dot grade equals to A, comparing equals to A. So it's actually a series of booleans, and what I get after I put this series of boolean into this locating square bracket is that I get only those that has a grade A right here. So this is the data frame that I get for student with A. So you might be wondering, I put a print statement here, but I did not put any print statement right here. So I should have clarified this earlier, but since I just realized this, so let me do some quick explanation. So essentially in Notebook, it works the same way as you are using the Python shell. So when you're using the Python shell, you don't have to explicitly put print there to get the output. So you can just put in a student with A, or maybe a variable to get the output out, but it must be the last line. So if it is not the last line like this one, I have to put in print statement right here to get this output out. So that's what's the difference by print and not print. But you might be confused like why there's no print but I get the output. So that's the reason. So moving on would be difference of ilog and log. So although it's a one letter difference between log and ilog, but there is actually a huge difference in the background. I mean, not in the background, but essentially there are a very huge difference how you use these two functions. So let's look into ilog first. So ilog is using index, as you know. The I stands for index. I mean, that's what I say, but that's how I remember it. So you have 0 and 3 and 0 right here. So you know that the first part is the row and the second part is the column. And I'm referencing 0 to 3, which means I'm taking 0, 1, 2, because the 3 is excluded, like what Qixiang said in the NumPy session just now. So I'm taking actually 0, 1, 2 only, and not 3. So I'm taking 3 rows, and I'm taking the first column right there, which is the name column right there. So we are still referring to the original one, which is this one right here. Oh, sorry, this one. So I'm taking name and I'm taking 0 to 2 because 3 is excluded. So basically I will get 3 people right here, Arming to Ahmad. Yep, so we after I run it, you see that we actually get Arming to Ahmad correctly. And in others, on the other hand, we have log here. So we are not using the index, but we are using the word keys. So you will see that there's a difference, although this is the most obvious difference because this you need to use index, but this you just use the column name to get the name, right? So that's a very obvious difference. But what is not so obvious is this one, which is you can see that the first one is 0 to 3, but the second one is 0 to 2. So what is happening? What on earth is happening right here? So in how to explain it shortly, actually in ilog we are indexing using we are referencing using index. So it is safe for us to exclude like 0 to 1 and 2, and I just exclude 3. But what if using index? Now I'm using numbers because the default index is numbers, right? So it's quite straightforward. Like I just 0 to, you might think that, okay, I just 0 to 3 and exclude 3. But what if I remove the first column and this whole thing doesn't refresh? So it will be 1, 2, 3, and so on. So how do I know, like, consider this as a word, right? It's not an integer, it's like a string like that. So consider that, how do you know where to stop? Like what comes after 2 is 3, but it might be 4 because after I remove the 3, the 4 is there after 2. So what log here wants is that we need to specify every element that we want to include. So essentially you need to include 0, 2 and the name. So the pandas know that, okay, I need to include the first 3, 0, 1, 2. So when I run it, you get the same output as before. So the next one will be reading from a data source. So here I'm creating a data set, a data frame in the notebook itself, but most of the time you might be reading external data source, like maybe a CSV file or SQL. Sorry, I lost. Okay. So you might be CSV, SQL, or JSON. So 3 of these are data files. They can store data, but in different formats. So what we are going to focus now is only read as CSV, but you can also check the Pandas documentation for read SQL. So you can read from a SQL file, or maybe you can just put in a SQL URI to read from that SQL to get the data. Okay, so you can see there's a method right here. So if you are reading from CSV, it's just as simply as applying this read CSV method function, and just plug in the directory, the path to that directory or to that file. So where this sample data resides. So let me just show you. So it's actually in Google Colab. You can click on this folder icon on your left to access the directory that you have. And you can see that there is a sample data directory right here. So clicking on that directory, you will see a list of all the files in the sample data. So I will not go into how do you look at this path, but it's actually a sample data, and inside sample data you have this California housing test.csv. So you can see inside sample data you have this file. So that's how you read the CSV. So if I run this, you'll see that it actually reads the California housing, and now we have 3,000 rows of data. So yeah, we look through all these columns, and before this, what we look into all these methods, right? They are actually just retrieving those data, and we need to observe and maybe explore the data. But what if we want to manipulate the data? So this is where it starts. So the first manipulation, the most simple one, would be adding and dropping the columns. So dropping here means removing the columns. So if we are adding the columns, it's just as simply as adding a new key value pair in the dictionary. So you can just think of the whole data frame as a big dictionary, right? So if you want to add a new column to that, you just have to pass in a new key. This will be the column value at the end, and you just pass in the new series here. So like I said just now, comparing each of the grade to A will just return a series of booleans. So if I run this, you'll see that you have a series called true, false, false, true, true. And it's appended to the back of the original data frame. Okay, so this actually works the same way, right? Like before this, when I create this data frame, right, you see that I'm actually using a dictionary for the data frame. So this actually like kind of, I would say, related, because you can just imagine it as a dictionary. So moving on would be, after I've done with this pass, maybe I don't want this pass column anymore. So how do I remove that column? So it's as easy as applying this function right here. This is also the Pandas function. So if you don't know, you can just search using the documentation just like before. And yep. Oh, sorry. So you can just pass in the label right here. So the label is actually what you would like to remove. So it's passed. And what is the axis? Axis 1. So what's the difference between axis and like 0 or 1? So let me show you like the documentation. So essentially, if you are not clear with anything, you can just always refer to this documentation. And you can see here, for axis, there are 2 types, with 0 and 1. So 0 means index. Actually, this actually means the row. So you're removing the row or removing the column. You need to tell the drop function to see what you would like to do. So for now, we are removing the column, right? So so what we essentially do here, is actually axis equal to 1, because I'm removing the whole pass column right there. So when I run this, you see that the pass column is removed, and we are back to this normal, not normal, the initial data set, the initial data frame that we have. So the next one would be dropping the column. So just now I said that 0 is actually dropping the row. So now I'll just show you in action what it does. So you can see here, the first one should be Arming, but Arming is not here anymore. So probably he changed his school or something. So the grade is not recorded anymore here. And there's something interesting that you can note here, like what I said just now, is that the index is not updated. So if you said that this is actually index, it should start from 0 to 3, right? So, but it starts from 1 to 4, despite removing the first one. So that actually means that this is not actually the index, but they actually turn into a word key already. You can take that as a word key. So merging data frames. After we have dropped and learned how to add and drop the columns, we might need, like sometimes we might read from 2 different sources, and we have 2 different table or 2 different data frames that we would like to merge it together. So this is quite a familiar, quite a usual procedure that we will take when we have like a few data source. So what we need to do here is that I'm creating 2 sample data frame. So this data frame A and data frame B. So you can see when you look at this dictionary, you can almost visualize like what this data frame consists of. So the first function that you use is concat, which just merge 2 together without any operations. Like it just merge together. So you can see that a duplicated column right here. So sometimes this is not what you want, because you would like to do a more SQL-like operations of merge. So you can use this merge function right here. So you can merge on here means I would like to compare the value for B, and if the value is the similar value, I will just merge them together. So I only have 1 column of B right here. So also this, you don't have to remember all the options that you have. You can just always refer to the documentation if you like to. So moving on will be rows. So after you know how to merge it, and sometimes after you merge it, you will have a lot of rows, and you will not know you will not have enough space on the screen, to be honest, to display like 3,000 rows. How would you have maybe some have big screens. I'm not sure, but mine is quite small. So to display the numbers of a few numbers of line only, because sometimes you're not interested in all of them, so you just need to look at a few of them. So like in this California housing, you can see we have 3,000 rows and 9 columns. So if you like to only get the first 3, so we just have to put this use this method, use this function right here called head, and then put in 3 right there. So what you'll get is the first 3 rows, and then tail will get the last 5. So tail is like the last 5 called observations of rows in your data set or your data frame. So data exploration, the most important one is info and describe. Both give you some insights of your data frame. So you can see that this column has how many values and what is the type of this column. So you can see that all are floats. So this another function is describe. So describe will give you the 5 numbers summary that here, which is being 25 and so on. So this, aside from this 5 one, you have also additional ones like count, mean, and standard deviation for each of these column. So I think it is it's worth noting that the column here, the describe only carries out this operation on numeric values, because obviously only numeric values has a mean, has a standard deviation. So they only apply on when the column D type is actually a float, or I mean numeric, like an integer float or something else. So if it is not numeric, it will just skip it. So that's the thing that you need to note. Right. So another thing is correlation. So correlation, you will seldom use that, so I'll just skip it. Just to tell you that there is this existence of this method right here. And unique is about getting the unique values. So you can see that in the previous data set here, data frame, sorry, you'll see that the grade has A, B, C, and AA. So we have 3 A's right there. So this unique, what this unique does is that it removes all the repetitions, and it will just show you the unique values that you have in the data frame. And value counts do the same thing. It's just that they have additional features, I would say, that it will count the occurrence of A and B and C. So you see that A is 2 because I'm using the updated one where the first arma is removed. So that's what we get here. missing values is NA or sometimes NaN, so it's either not available or not a number. So I mean, not a number is NA, but NA is not necessarily NaN, but that we won't get into that for this session. So here I'm mocking the situation where you have a missing value. So I just add a new column right here that has a NaN, which stands for not a number. So there's a way of removing this NaN. So you can just call drop NA. So you will drop this whole records here, whole observation right here. So you just leave with Abu, Ahmad, Siwa, as you can see in this output. Or in the other way, you can just fill in the NA with a -1. So it will just returns -1 for the NA value. So it might be not obvious, like why do you want to replace it when it's only one NaN? So you can just index that place and just put a -1 value to there. But imagine you have a 3,000 data set and 3,000 rows of data set and maybe like just now 9 columns, and you have a lot of NA values. So this comes into play, right? And aggregation is about grouping the values and also to count. It's not necessarily count. You can have a lot of types of aggregation function, but one of them is count. So you can group up the data set by the grade. So this is a reference, like how should Pandas group the data for you? So it's like based on grade, you group them into a few groups and you apply this function. So what you get is actually you aggregate by A. So it's like A has 2 names and 1 mark and so on like that. So moving on, for this one, it's nothing special. I just want to show you like what is this whole group, like after you apply group by, how it groups the data up. So it doesn't print prettily, but you can I will help you to highlight the part. So it's like when I group by A, I have this these 2, 3, and 4, which is Siva and Akao. It has a grade A and 68 marks. So basically, this is how it groups up the data for you. So because you see that I iterate through the group and I print out the group here. So you can see that. So the last thing is about exporting. So sometimes you will do some data processing in your notebook, and sometimes you would like to export it out. So Pandas has a function called toCSV, just like the read CSV, but now you're exporting out of your notebook. So you just apply this. So you can see here, how do you use this method is that you just put in a string that consists of the path to that the name of the file that you would like to create. So you can see here, actually in sample data, we do not have the student data.csv, but if you run it, you see that you'll see a sample data. Let me refresh the directory. So you can see the student data.csv here, right? So it means it export the data out to this file right here in a CSV format. So another way is to export it as a dictionary. This is not exported, but it's some sort like convert into a dictionary. So you see it like this. All right, so that's all for for Pandas, where you learn how to retrieve those values out, and you know how to read those data from the data source, and you know how to manipulate the data, like dropping the columns, and also fill up the missing values or drop the missing values. And also you learn how to apply functions by grouping up all the data set, or grouping up by one of the column. And yeah, that's pretty sums up our Pandas session. So for further readings and learning, you can go to the Kaggle tutorial. This is another Kaggle tutorial that I think is quite useful. And also Pandas documentation, the official one, and also Pandas cheat sheet prepared by datacamp.com. So you can look into all of this further readings. All right, so we have done the Pandas session, and moving on would be the hands-on session, which is quite interesting to me because we are using a UFO data set. So we try to explore like all those UFO sightings that is recorded in that data set. So I think you have this link to the notebook as well in the chat, right? So you can just click on that and you'll be redirected to another notebook with a different name right here called Session 2 Hands-On. May I know if you can see this Session 2 Hands-On on my screen right there? Okay, so I think you are able to see it, although no one answered me, so I just assume it as a yes. So Right. So in this hands-on session, we'll be using pandas a lot. Like the whole hands-on session will be about pandas. And how I'm going to conduct this pandas hands-on is that I'll give you some time to try on your own. All right. And after that we'll announce. We'll disclose the answers for that section right there. So before we actually get on to into exploring the data and stuff. So before that, I said that most of the time we'll be reading data sets from external sources. So in here, I'm actually using Git to clone the repository, the GitHub repo, and inside the GitHub repo there is a data set for us to explore. So essentially, this is what it works. So that you will see that there are two big section here. You have data pre-processing also, and another start here section. You can press on this triangle to collapse and expand. So we'll just, for this session, we'll just start from the start here part, obviously, and we'll not go into the data pre-processing, because this data pre-processing actually involves a lot of I would say more advanced pandas operations to clean up the data, because while I'm trying to prepare this notebook, I found that the data are not clean enough. So okay, it might take time to initialize and connect it, and also take time to clone. So we shall wait for a few seconds. So if you like to follow along, I mean, you have to follow along the hands-on, because this will makes you more familiar with the pandas methods or the functions that you have learned just now. So you just have to press on Control Enter to run it. But if you like to more convenient, you can press on Shift Enter, so that after you run this cell, it will move to the next one. So like what I do right now. So you just run the first few cells right here, until you reach the start here cell. Right, so you can just Shift Enter. All right, so now you reach the start here. So may I know if everyone reached the position where I am right now? You can reply a 1 in the chat. Yeah. All right, thank you, Sharafuddin. Okay, thank you, Jahan. So maybe I'll wait for, all right, thank you. I'll wait for another 1 minute to make sure that everyone is following. Yep. Okay, thank you, Ziyi. Thank you, Amos. Okay, thank you, Richie. Okay, I think that's the maximum amount of time that I could wait for. So okay, all right. So you can see here in the start here section, we have a few questions. Some are not questions, some are just statements, but those are actually the questions that we would like to know about the data set. So essentially, the first one will be visualize the first 6 rows of data set. So before that, I think I would need to tell you that after cleaning up all the data, right, what you have lastly is actually the data, the variable called data. So in this data, you have the whole data frame of all the clean data. So you can just use this data variable to explore those data in this variable, essentially. So for the first one, I would like you to try on your own, because I've actually gone through something similar, just that I just changed the number of rows. So that's a hint. So I would like you to try on your own, and maybe you can put your answer in the chat. Yep. I'll wait for maybe, I think 1 minute is sufficient, but I'll wait for 2. So after, if you found the answer, maybe you can put in the chat box it's just a one-line answer. So that's another hint. So the first hint is that I've actually gone through this in the previous notebook. And the second hint is that it's only one line. All right, thank you, Amos, for the answer. Can the others tell whether this is correct? Maybe you can react if you think that it is correct. Yeah. All right, seems like a few people agree with that answer. Okay, I think, all right, numbers is increasing. Wow. Nice, all right. Right, I think that's the most amount of time I can wait for. So essentially this is, yeah, is data.head, and you're just passing in 6 here. So maybe you can just try out what if I don't include a number inside. So what will happen? Maybe someone can show, or maybe can reply in the answer in the chat section. What will happen if I did not include this number inside the head? So while waiting for the answer, we just move on, right? So because time doesn't wait for us. Like, all right. So the next one, I will be skipping some of the parts because I think some of them you are able to do it if you know how to do some of the parts, right? So I just highlight those important parts. So all right, so it seems like the column duration hours minute is not that useful. Why is it not useful? Let me give you some context. So essentially, this is a data set of UFO sightings. So it is about you can see here, you have date, time, city, state, country. So essentially, there are a few countries that they see UFO. So I'm not sure Malaysia have or not. So one of the questions would be, does Malaysia has any sightings in this data set? So that is the question after this. So we just focus on this one, which is to remove this duration hours minute because it's not relevant. Why it's not relevant? Because it is just converting these seconds into hours and minutes. Maybe you can do some simple calculation like 2,700, how many minutes is there? And also 7,200, how many hours? So what we need to do right now is that we need to remove this duration hours minute because first of all, it is not numeric because you can see that minutes it's not that sometimes it's not that useful for us to do some analysis, and also it actually has the same meaning both of this column. So I would rather pick the number right here, the numeric column. So that's I mean I choose to pick that. So yeah, you have to just follow for this session, right? So you can make on your own decision after this. Right, sorry about that. So it seems like the column duration hours minute is not that useful, and you would like to drop the column. So yep, I've actually gone through this function as well. So maybe you can type in your answer in the chat box. Yep, G got the right answer where there are only 5 rows by default. So that number is actually like customizing that method, that function, I would say. Like if you pass in 3, you will get the first 3. If you don't pass in anything, it will return the first 5. Yep. A thumbs up for that. All right, I think my screen lags again, so I need to unshare and reshare. All right, so I think it's better. Okay, so I'm waiting for answer for this dropping the column. So I'll wait for maybe another 1 minute because we have another more interesting question to answer, which is, does Malaysia has a UFO sighting? Right. All right, so I think that's I can only wait till now. So we shall proceed. So in order to remove this duration hours minute, right, you need to data is the data frame that we have right here. So there's a function called drop. I think I've gone through this before. And in drop, you have yeah, it's here. So you have you have a few options here, but what you focus on is just this. So labels will be what we would like to remove. So here in this case is the duration, hours, minute, right? Okay. You have to type it this. You have no choice because that's my choice. So you have to follow for the hands-on session. So the axis can be 0 or 1, but in this case we are dropping a column. So dropping a column, which means we are choosing 1 instead of 0. As you can see here, 0 is the row, 1 is the column. So yep. So this will drop the column. So let me run this. Would I get the new data frame? Oops. You can see that the hours, minutes actually remain in the data frame. So why does this happen? So it's actually what this drop function, or maybe someone can answer this. Someone wants to say, oh, okay, Jiaheng. Do anyone knows, yeah, in place equal to true? Thank you, Wanjun. All right, so maybe I'll just proceed. So it's actually, there are two options do you want, but for this case, I want to change it without in place. So there's two ways to you want to do it. You can just put it in place equals true. So how do Wanjun know this in place? Maybe he memorized it already, I'm not sure. But for me, how I know it is that I look into the documentation and I see there is an in place option right here. This is true or false. By default, it's false. But so this is one of the way. But sometimes you want to be more explicit, like so you can what you can do is data equals to. So what you're doing here is you're replacing the one before into the new one. So this drop by default is in place equals to false. So in place equal to false means it does not change the value in place. So it is creating a new data frame with the change part. So this is what we are doing here, where we are replacing this data to the new data frame that we get. So if I run this, you'll see that the data duration, hours, seconds, hours, minutes, hours. I'm not really sure. Hours, minutes, sorry. So hours, duration, hours, minute is removed right here. Okay. So yep, let's move on to this one first, because before we move to the does Malaysia has a sighting. So for summary, so essentially what could you replace this with the actual method that the actual function that you will need to get the summary of the data. Like you have to get the 5-number summary and also the some standard deviation and stuff, right? So as usual, I wait the answer in the chat. Now maybe 30 seconds. Sorry about that. All right, thank you, Wanjun. Thank you, Wei Xing. Right, so I think I shall proceed. So, yep, you have gotten the right answer, which is described. And just run it. And you'll see that you get the 5-number summary and also the count and mean, and also the standard deviation. So you might be wondering why this date time is numeric, because it doesn't exist in the previous notebook. So this is where I want the describe function to assume that date time is a numeric column, because date time actually can be expressed in epoch time. So if you don't know about that, so that's the reason of this date time is numeric. So how do you know this? Refer to the documentation, right? So before we end, maybe can someone tell me, does Malaysia has a UFO sightings? Maybe I'll wait another, this one I think I'll just give 1 minute. Okay. Yes, Hoji said there is a UFO sighting. where it could be. Will it be in KL or something? Not really sure. All right, sorry about that because we are running out of time. So what I'm going to do is I'm going to show you how to do it. Oh, sorry. Okay, so does Malaysia have UFO sightings? In order to know that, because we know that there is a country column right here. So this country column actually records all the country where this sighting happens. So what we have to do is we just get the unique country, right? So data.country, by referring to this data.country, we are taking this country column only. So now we are sort of like slimming down our scope, right? So we just focus on country, and we just get the unique value for the country. Right. So what you'll get is US, NAN, GB, I'm not really sure. CA, I think is Canada, not really sure. Australia, maybe. But there is no country start with M. So I'm quite sure that there is no sighting in Malaysia. So I'm not really sure. What do you think? So of course there might be, but because there is a missing value here, so there might be sightings, but we couldn't make that assumption, I think. Yep. So I think that's all for this hands-on session. So after this, we'll be sharing a answer notebook for this this whole hands-on session, so you can look through. But before that, I would rather suggest you to do it on your own and try if you could answer all of these questions. Like there's another interesting one, which is which shape of UFO can we see more often in the morning, and also what time in the hour, what time in the day should I look out the window to search for UFO? Right, so maybe you can try to explore the data and find the answer for that. Okay, so I think that's all for the hands-on session. And we shall move on to, let me share another screen. The next thing would be Q&A. Let me share the slides again. So we've done this. So now it's a Q&A session. So we'll start with, we'll accept questions. Yeah, yeah. Nice to see you found interesting fact there, right? All right, so that's all for the hands-on session, and now it's a Q&A session. We will accept question for maybe in 1 minute if there is any, and we'll try to answer it as soon as possible. So maybe before we share out the answer and you found some interesting fact, you can also share it in this chat right here so that everyone can have a look and maybe try it on their own to find the same fact that you found. Yeah. Okay, it seems like there is no. Where do we fill out the attendance? Oh, maybe. Qi-Xiang, can you share the link again for the attendance? Right, so that is the link to the, yeah, no problem, Wei-Xin. So thank you, Qi-Xiang, as well. All right, so if there's no questions, we shall move on to the photo session, maybe. Yeah, so Qi-Xiang will be taking over this session. Right, thank you, Qi-Xiang. So can every one of you turn on your camera to see your beautiful faces, right? All right, so this session over to you, Qi-Xiang.
Yeah, so everyone, please, if possible, just open your cam. Yeah, we will have a photo taking session right now. Yeah, so anyone else? Yeah, all right. So we will be taking the photo right now. So 3, 2, 1, smile. All right. So thank you everyone that opened your cam. Oh
Oh yeah,
yeah.
Xishan, I
So
think we
we
need
have
another post
another
right there.
yeah our GDSE host. Yeah. So can you guys just open back your camera again? Yeah, so you're trying to get our GDSB host. Yeah. Okay. So 3, 2, 1. Okay, thank you guys. Yeah, thank you for opening your cam. Yeah, so right now, we are distributing a feedback form to you all. Yeah, so I will be, so Jumpin will be sharing the slides. Yeah.
Yeah, wait for a moment. I'll be sharing the QR code to the feedback form.
Yeah,
So
if
your feedback will help us to improve. Yeah, Xishan.
Yeah, so I will be sending the feedback form link in the chat box as well. Yeah, if you cannot like scan the QR code.
So we really hope that you will fill up that, because your feedback actually helps us to improve over time, because we have another 2 sessions at the back. So yeah, your feedback really matters to us. Thank you. So I think that's all for our workshop session 2. So see you in the next one. Thank you.
Thank you.
Thank you.